All right, in this video, they're asking us to find the p-value for two different examples. In the first one, they tell us that the mean is greater than 10 is the claim. And because of that greater than symbol, it means the claim is also the alternative hypothesis. And because it's the alternative hypothesis, we can tell that the test is a right-tailed test since it has a greater than symbol. That means we should draw a bell curve here as a visual aid to do our p-value. We'll label a z-axis at the bottom, centered at 0, like all standard normal curves are. And then we'll place our test stat on the drawing. Relative to 0, 1.02 is on the right-hand side. And then here's where the right-tailed test part comes in. If we have a right-tailed test, we have to find the area to the right of the test statistic. Now, even if the test statistic was on the other side of the curve, because of the right-tailed test, we'd still find the area to the right of the test statistic. So it doesn't matter where the test statistic lands, it matters that it's a right-tailed test, and the rule is to find the area to the right of it. So let's go look up 1.02 on a z-chart. That's all we have to do, really. So we'll come down here till we see 1.0, and then over to 1.02, and you get the answer 0.3461. So that's the area here, though, 0.3461. We want the area in the tail, and the way you would do that is just take the whole half of the curve's area and subtract off the part we know, 3461, and that'll give us our answer. So 10 minus 1 is 9, and 9 minus 6 is 3, and 9 minus 4 is 5, and 4 minus 3 is 1. So we get the answer 15.39, or 0.1539. Okay. So there it is. That's your p-value for the first example. For the second example, the claim also has a symbol that belongs to HA, or the alternative hypothesis. So we'll go ahead and say that it's a two-tailed test in this case, right? Because not equal to means a two-tailed test. So we'll draw the bell curve. Put a 0 in the center of the distribution. Since it's a negative test stat, it'll go on the left, so negative 1.11 is over here. And the rule for a two-tailed hypothesis test is that you find the tail area and then you double it. So let's go find this area and then we will multiply by 2. So let's look up 1.11 on our z-chart. So here's the 1.1 row and here's 1.11. So it's 0.3665. So 0.3665. And we're going to do the same trick we did before. We're going to subtract from 0.5 to get the area that we're looking for, the tail area. So I have 5 and then 3, 3, 1. So 13.35%, but then we have to actually do what? Multiply that by 2, or you could just add it to itself, right? So 26.70%, or 0.2670 as a decimal. So this is your p-value in this example. So it's very important you remember to multiply by 2 for a two-tailed test. And it's also important that you realize that we're not always finding a tail area. If the test stat, for example, in our first problem was over here, we still would have found the area to the right. It just would have been all of this area, right? It would have been all that area all the way over. So it's just important that you don't get into the habit of thinking a p-value is always a tail area. It doesn't have to be.